Okay, lesson 71. First question is, what is a quadratic equation? A quadratic equation is an equation of this form, ax squared plus bx plus c equals 0, where a, b, and c are numbers, and a is not 0. So this means any equation where you have an x squared term and it is the highest power of x. We have been solving quadratic equations for quite a while now, and we've learned two methods for solving a quadratic equation. The first is factoring using the zero factor theorem. So, for example, if we had this equation x squared plus 2x minus 15 equals 0, we can solve this by factoring it. So we can factor it into two binomials, and then we use the zero factor theorem. If you multiply two things together to get 0, one of them has to be 0. That's the only way to get 0. So either x plus 5 is 0 or x minus 3 is 0. So x could be negative 5 and x could be 3. Those are the only two solutions, roots of this equation. They are the only two numbers that will make that equation a true statement if you put one of them in for x. That's what it means for those two numbers to be the solutions or the roots of the equation. They make the equation a true statement. If an equation is not factorable, we've learned to solve by completing the square. And when we do that, we are trying to find a number that if we add it to x squared plus 3x, it will make that a perfect square trinomial. That would be a trinomial that if you factor it, you will get two factors that are exactly alike. You'll get a perfect square. And we're doing that so that when we do that, we can take the square root on both sides of the equation to solve for x. So that's another way we can solve a quadratic. According to the pattern we see when we have a perfect square trinomial, the constant term is half the x coefficient squared. And so that is what we're going to put in these blanks. So 3 halves squared is what we're going to put into the blanks, 9/4. So if we add 9/4 to both sides of the equation, which is totally legal, that will make the left side of the equation a perfect square trinomial. And that trinomial looks like x plus half the x coefficient, quantity squared, and that's going to equal 3 plus 9/4. And that would be x plus 3 halves squared is equal to 12/4 plus 9/4, which is going to be 21/4. And so we can take the square root on both sides of the equation. X plus 3 halves equals plus or minus the square root of 21 over 4. And that means that x is equal to negative 3 halves plus or minus the square root of 21 over 2. So that's how we solve a quadratic using completing the square. And I think most of you have that down pat pretty well. All right, so now what we're going to do is we're going to find out that we can actually complete the square for every single quadratic in the universe, and then we won't have to do it anymore to solve a quadratic equation. We will still need to know how to complete the square for other reasons, but we won't have to use it for solving quadratic equations anymore. And the way we're going to do that is we're going to take a totally generic quadratic equation, ax squared plus bx plus c equals 0, where a, b, and c could be any number. A has to not be 0 because it has to be a quadratic, but we are going to just solve this one. And once we solve this one, we can use that formula for any quadratic. And so the first thing we have to do, remember, when you're completing the square, is you have to have 1 as your x squared coefficient. Right now that is a. We don't want that, so we're going to divide everything by a in this equation so that we can get a 1 for our leading coefficient. So if we do that, we'll have x squared plus b over ax plus c over a equals 0. Now we're going to complete the square, so we're going to move that c over a to the right side of the equation and leave a blank next to the b over ax, and also a blank on the other side, because whatever we do to one side, we have to do to the other side. So what goes in the blank? Half the x coefficient squared. So b over a, if you take half of b over a times 1/2 is b over 2a, and then you're going to square that, and you're going to add that to both sides of the equation. And if you do that, you are going to have x plus half the x coefficient quantity squared is equal to negative c over a plus b squared over 4a squared. Now, You're going to add the right side together. You're going to get a common denominator and add that up. So you'll have x plus b over 2a squared is equal to negative 4ac over 4a squared plus b squared over 4a squared. And now I've got a common denominator on that right side. I can add it up, and I'm going to rewrite it this way. And now I am going to take the square root on both sides. So I'll have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. Now notice I just changed the order of the terms in the numerator. Just it looks nicer if you put the b squared first. All right, and then I'm going to subtract b over 2a on both sides. So I'll have that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And notice on the right side, I had 4a squared, the square root of 4a squared in the denominator. So that was 2a, which means when I subtracted negative b over 2a, I already had a common denominator. And this is what I ended up with. And this is the quadratic formula. This is a formula that for any quadratic equation, you can find out what x is just by putting the coefficients into this formula in the right order. So this is how you use the quadratic formula. You would look at your quadratic equation that you want to solve, 3x squared minus 2x plus 5 equals 0. And you're going to look at your a, your b, and your c. A is the leading coefficient, which is 3. B is the x coefficient, which is negative 2, and C is the constant, which is 5. Now all we need to do is take those values and put them into the formula to find out what x is. So putting in negative b, which is negative 2, plus or minus the square root of b squared minus 4ac all over 2a. And now I'm just going to simplify that. And I'll have 2 plus or minus the square root of 4 minus 60 over 6. And then I will simplify it further to 1/3 plus or minus the square root of negative 56 over 6. And then I will use Euler's notation to rewrite that in the right way so that I can simplify that radical, reduce it to 2 times the square root of 14 I over 6. And you would reduce that to 1/3 plus or minus the square root of 14 over 3 I. And notice how I wrote it with the real part first. 1/3 is real, plus or minus the imaginary part, completely separate, square root of 14 over 3i. That is the way to write a complex number that has a real part and an imaginary part. Real part first, imaginary part second, completely separate. Okay, let's solve this one. X squared equals 3x plus 28. First thing we have to do is get everything on one side of the equation so that it all equals 0, because anytime you're going to solve a quadratic equation, you have to get everything on one side and set it all equal to 0. So now we have done that. Let's figure out what our a, b, and c are. A is our leading coefficient, which is 1, x squared. B is negative 3, the x coefficient, and C is negative 28, the constant. And now we just plug all that into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Memorize it. Plug all the numbers in. And now we're going to simplify that. And we'll simplify it further to 3/2 plus or minus the square root of 121 over 2. And you may notice that the square root of 121 is a whole number, 11. We have 3 plus or minus 11 over 2, which is going to be 7 or negative 4. Now, if I get solutions that are whole numbers, these are the roots or the solutions of the equation. If I get solutions that are whole numbers, it tells me that I forgot to check and see if this equation was factorable before I used the quadratic formula, because it definitely was factorable or I wouldn't have whole number solutions. So here's the thing. If the equation is factorable, just factor it. Don't use the quadratic formula if you have a factorable equation. So let's go back and do that. X squared minus 3x minus 28 equals 0. Factors into x minus 7, x plus 4, and therefore x minus 7 must be 0, which means x would be 7, or x plus 4 must be 0, which means x would be negative 4. So that would be how you would solve it using factoring, and that is how I would prefer that you solve any factorable quadratic. So if the book tells you to solve a quadratic equation by the quadratic formula, when that equation is factorable, then factor it. Don't worry about it. Just factor it. That should be your first step whenever you're solving a quadratic equation. Check if it's factorable first. If it's factorable, solve it that way. If it's not, use the quadratic formula. Okay, lesson 72. We're going to talk about negative angles. When we use polar coordinates to describe the location of a point in the xy plane, we use a positive angle to indicate rotation in the counterclockwise direction. So if I was going to go 90 degrees, I would start at 0 and I would twist in the counterclockwise direction, 90 degrees. If I have negative 90 degrees, what that negative sign is telling me is to rotate in the clockwise direction. So we've already been doing this with positive angles. Now we're going to be doing polar coordinates where we may have negative angles. The only thing that negative tells you to do is just go clockwise instead of counterclockwise. We know that we can use rectangular coordinates to describe the location of a point. As a location, this particular point is 4 units to the right and 3 units up. We would have the rectangular coordinates 4, 3. We have learned another way to locate a point in the plane, and that is by using polar coordinates. And to do that, you say how far out from the origin you go, which in this case is 5 units out from the origin, and the angle is going to be 36.87 degrees. And we would use polar coordinates that way to tell someone how to get to that point. Now, your book, as you know, writes polar coordinates this way with this little bracket, like so. The standard notation for polar coordinates is to write the radius, that is the distance from the origin to the point, first in parentheses, and then write the angle. And that is the counterclockwise angle from 0 degrees. That's how we could express this point in polar coordinates. Now we're going to look at another way to get to that point using polar coordinates, and that would be to go in the clockwise direction. So if we go in the clockwise direction, we're going to have to go 360 minus 36.87 because we want to go clockwise all the way to that radius. And so we're covering the whole circle except for that 36.87 degrees. So we figure out what that is by just subtracting 360 minus 36.87. And now we can write this in this form, 5 negative 323.13 degrees. You would write 5 comma negative 323.13 degrees in parentheses. And please try to remember that notation is super important in math. It matters whether there's a degree sign. It matters whether there are parentheses. It matters whether there's a comma. All those things matter. So please be very careful when you're writing notation to include all the necessary pieces of that. So if we had something like 4 negative 210 degrees and we wanted to express that in rectangular coordinates, we would do it the same way we've been doing these problems with positive angles, except that to graph our angle, we're going to have to use clockwise rotation instead of counterclockwise rotation. So we still start at 0 degrees and we start rotating clockwise until we get to 210. So 90, 180, and then how much more do you have to go? You have to go 30 more degrees. And so you're going to end up like that when you go 210 degrees in the clockwise direction. And the angle that you're going to work with in your triangle is 30 degrees. And so now you would just use your sine and cosine to find out what the horizontal and vertical legs of that triangle are going to be. So we know that sine 30 degrees is going to be opposite, which is A, over hypotenuse, which is 4. And cosine 30 degrees is going to be adjacent over hypotenuse, which is B over 4. And then we will just isolate A and B. So 4 sine 30 degrees is going to be your A, and 4 cosine 30 degrees is going to be B. And if you remember your 30, 60, 90 triangle, that's going to tell you that A is 4 times 1/2, which is 2, and B is 4 times the square root of 3 over 2, which is just going to be 2 times the square root of 3. And now you need to write your rectangular coordinates. We're in the second quadrant here. In the second quadrant, X is negative because when you start to graph a point here, you go left and up. So second quadrant will have a negative X and a positive Y. Negative 2 square root of 3, 2. And those are your rectangular coordinates. Make sure they're in parentheses with a comma between them.